This has been organized by Holistic Learning Platform. We really thank them for this. We are going to be going through the A-level section of biology, probably paper 2 or theory. We are going to be doing a number of questions here. And I will wish this to be completely learner-centered since we are in the last moments towards UNEB, such that we can try to put right just according to your output or the product you'll give in response to a particular item or question. So I will request that this session shall be fully interactive, though we shall try to manage on things concerning time and others. But I would wish for any question, I will be very happy if it is being responded to by a learner first before I can come in. And I hope we become very sensitive like we've always been, like by raising up the hands and giving the responses, such that we can really see whether we could be maybe not polished up well, such that we can try to improve on that, other than me just giving what I have. So I've already done the introduction. This is biology. Biology has 3 papers. It has paper 1, paper 2, and paper 3. Paper 1 and paper 2 are theory, and the paper 3 is practical. But for today, we shall be going through the whole theory, that's paper 1 and paper 2 combined, and we shall mainly learn by using examples of questions from different topics. I've used the resource material from a particular workshop or seminar, which you can use to get questions, and then we can possibly get the responses. So I will start straight away. I only hope that question is so visible. Okay, there is a question here. We have figure 1A and figure 1B, which show the physiological changes that occur in a fruit as it ripens. We have figure 1 here, figure 1A. We have one graph showing a decrease in chlorophyll as time goes on. And then there is another curve here that is showing an increase in carotenes as time goes on. And then in figure 2, actually figure 1, part B, we have respiratory rate increasing with time, after which it reaches a peak and then decreases. And then you have the sugar concentration increasing and then leveling off towards the end of the experiment. I see the people are straining to have a look at this. I don't know. Let me try to zoom it maybe. I don't know. I hope we can see it. If we can see it, then the better. So we have part A. Part A set the relationship between sugar content and respiration rate during ripening of the fruit. I don't know if there is someone there who can give us an idea of how they could attempt this item. Yes. Please raise up the hand just in case. Raise up the hand. You'll definitely appear on the screen here. Then it's just about giving the response. Part A. It's not about giving the correct answer. It's just giving what you think, and then we try to polish it up where need be. I see the Butogota Trinity College team there. Perfect. You can unmute.
Yes.
Unmute. Okay, I can hear you now.
Yeah. You have told us to state the relationship between sugar content and respiration. I think the relationship is sugar content sugar content increases as the rate of respiration also increases. So that means sugar content is largely depending on the respiration rate.
Okay. Okay, that's good. That's according to them. That's their response. That as the respiration increases, the sugar increases. Okay, that's according to the Butogota Trinity College team. Can someone try to maybe shine more light towards that? Like, how right is that statement? They have said as the sugar content increases, the respiration rate increases. I don't know which one is leading to the other. Is there anyone who can try to put that right? Maybe. Please just raise up the hand. It seems no one. I see people are still logging on, so we shall continue. Now, when you are giving relationships, when you are giving relationships, we often, I think I'll first take us here to how we give relationships. Okay, I think it's not part here. Sorry, I must have put it elsewhere on the graphs, but it's okay. We can continue with our item now. When you're giving relationships, of course, we can use the word as, we can use the word while, okay? But in this case, when you are stating a relationship, where here they just said state the relationship, they didn't ask you to explain. In that same vein, it means that you're just going to simply state the relationship. But of course, you are going to use trends to state the relationship. Why? Because the relationship is not uniform. We are saying that the respiration rate is increasing, attaining a peak, as the sugar content is still increasing. Meaning there are some variabilities in the increase, or there are some variabilities in the trends of the respiratory rate and then the sugar content. So we can use the word as, for example, to state the relationship. And this is how we could say it, for example. We could say, as the respiratory rate increases, the sugar content increases. Some people can ask that, should we include the X scale? Yes, like for example, in this case, we should. Why? Because we are seeing that there are some variabilities in the increase. So meaning it is right to say that as the sugar content increases, as the respiratory rate increases, the sugar content increases, or we can even set the direction. For example, as the respiratory rate increases rapidly, the sugar content increases rapidly, comma, then, but we are seeing that respiratory rate is attaining a peak here. So we could also have said, as respiratory rate increases to attain a peak, or as the respiratory rate increases rapidly to attain a peak, comma, the sugar content increases rapidly. Then, as the respiratory rate decreases rapidly, the sugar content increases rapidly to attain a maximum. Okay? But in some scenarios, they usually just describe. For example, you simply say from 1 to 3, as the sugar, as the respiratory rate increases rapidly to attain a peak, comma, the sugar content increases increases rapidly. Then they just continue, okay? For example, in this seminar, they used that. They said from 1 to 3, as the respiratory rate increases rapidly to attain a peak, comma, the sugar content increases rapidly. But we can't say that it is increasing rapidly to attain a peak. Why? Because this one attained the peak when this one was still increasing. So you can't say this one increased to attain a maximum. Rather, we shall pick up from 3 to 7. Okay? So that from 3 to as the respiratory rate decreases rapidly, the sugar content increases gradually to attain a peak. To attain a maximum. Now, there is a difference between a peak and a maximum. For a peak, it increases, then it decreases. It attains a peak, then it decreases. And then for a maximum, it increases, then it stays uniform. So usually after for example, when you're describing a particular graph, and then you say that it attains a peak, then after you say that, you say that then it remains constant. That is wrong. Why? Because that was a maximum. A peak is only when it increases to attain the peak, then it reduces. Okay? All right. So we have there our two relationships. First one, we said that from 1 to 3, as the respiratory rate increases rapidly to attain a peak, the sugar content increases, increases rapidly if you're taking it uniform. Okay, but sometimes that the direction doesn't matter, but of course we can't take chances, so you can easily state it like that. And then another relationship is from 3 to 7, as the respiratory rate decreases rapidly, the sugar content increases gradually to attain a peak. Okay, so that one could have been our relationship. And at least the way the Togota Trinity College was saying, it was almost familiar to that. But the only new things we should add is, here we quoted the range, okay? And another thing to quote on the range is, please, for example, here they say that days. Also put days, don't use D. For example, someone can say that from 1 to 3 Ds. That is wrong. Also, don't write those figures in words. Don't say that from 1 ONE to 3 THREE. That is wrong. Simply state the digit. And put the units which they have put there. If they have put days, put days. If they have put seconds in full, put seconds in full. If they have just used S, also use S. I hope we are good to go there. So we can proceed to the part B. Okay, I see Butogota team has something to say here. Okay, you can unmute.
Yeah, what I wanted to know, if I'm stating the range, and I say from 2 to 3 days, and another person says from 2 days to 3 days, what is correct and what is wrong?
Come again from?
I wanted to know if someone states when he's stating the range and says from 2 to 3 days, and another one says from 2 days to three days. What is correct and what is wrong?
Oh, I get you. Now he's saying simple on units. Say that should you put on the first figure and the second figure, or should you put on one? Now, of course, there usually when you put on the last one, it is okay. But also when you put on the first one and the second one, it is okay. But actually, I would ask you to take the second one, or putting on both. Okay? But also putting on the last one alone is okay. But you can put on both also. Okay, can we proceed to part B? Give an account for the relationship given in A above. Give an account for the relationship given in A above. I see my Masheruka Girls Secondary School here. Masheruka. Masheruka? Okay, any other person who can give the idea there? Any other person? Yes, Morlem Girls. You can unmute. Morlem Girls. You can unmute. Unmute. Yes, thank you.
Okay, sir. Like now, when I'm describing the relationship, maybe like
Yes,
if I
please.
say from 1 to 3, then I put the date and the interval. Then I continue from the other one without saying that from this day to this, but I'll be using the same color. Will I be correct?
Come again.
Like, when I'm describing,
Yes.
then I'll say from 1 to 3 days. Then I'll use
Yes.
the column. Then I'll put what maybe it increases. Then now again the second description, I'll not say from this day to this, but I'll be using the same column. Will I be correct?
Your meaning is that from 1 to 3 days, the
Yes.
rate of respiration increases rapidly, right?
Yeah. Mm.
And then you continue say then gradually.
I'll be using now the same column. I will not say again from this day. Oh, I'll be using the day.
You just be continuous.
Yeah.
Yes.
Uh, okay. Now that one, if you're stating a okay.
See the network what? Oh yeah, it's another people.
It was a small network issue. Now, I don't know. I think let me briefly take you through a description, how to describe such that we can get this well. Okay, I think it's right for us to briefly go through this description of how to analyze the data. Let's go through it briefly to answer Morlem Gao's question. Now, when you are describing, okay, there we are. I know this one shall be very important for us. Where are these Morlem Gaos? I first mute them. Okay, like you see when we are describing trends, we simply start with the range on x-axis, okay? Followed by descriptive word or statement words used. So for example, I usually just like saying that, now for the x-axis, like I've shown down here, e.g. from 0 second to 10 second, that's the way we simply say it, okay? And then the rate of enzyme activity increases gradually or increased gradually. Now, the also question is there is, the question is, do I use past tense or present tense? Sometimes using present tense is okay. But of course, don't use the future tense, okay? Don't use the future tense. Use the present tense or past tense, okay? But usually the simple thing is, there are some point they're describing, they can use words like from 0 second to 10 seconds, there is a drastic increase. Sometimes such words cannot make a lot of sense, okay? Just use simply quote in the brain, GRC, gradual, rapid, constant, okay? That's when you're describing trends. But, so you can, that's the same describing trends, changes, or variations, okay? But the only difference comes if you are describing relationships and effects. That is a bit different. I think we shall do it briefly here before we can proceed to the next questions, because it is also very important and it is a question which cannot be missed. So when we are describing any graph, we start with the x-axis, okay? Followed by a descriptive word for the y-axis. So independent factor is described quantitatively, or the x-axis is the independent factor, which we describe quantitatively, or we use figures. For example, now as there we use the from 0 days to, from 1 day to 3 days. Okay? That one we use numbers, and say that we use figures, digits, not words. Okay? And then for the y, we use qualitative descriptions. And that's when we quote GRC. It can be a gradual increase, a rapid increase, or a constant. I put here in bracket that almost. Now the question is, when do we use almost? We use almost if a graph is not plotted to scale. For example, like the graphs I showed you there, they were not showing the squares of the graph paper. So those ones, we just use almost. So meaning that it is almost constant, okay? When you're describing that time when it has reached the maximum. But for rapid, of course, you can get and the gradual. So we simply use those ones. Now, the only difference is there are some graphs which you can see. Maybe you can't differentiate. Here it is very rapid. Then this side is also, it looks like it is rapid, but it is a bit different. Now, in that case, we introduce in the word very. For example, for the first one, you can say it was rapid. Then the second one, very rapid. Or you can say this one maybe was very gradual. Then the other one was gradual. That's when you bring in those ones. But you should always just use GRC. Also, it is very wrong to miss out on the word increase or decrease, apart from for constant. So for constant, of course, you can't say there is a constant increase. No. But if it is constant, it is constant or almost constant. But for a gradual, don't miss out on the increase or decrease because it gives it direction. So you can say from 0 seconds to 10 seconds, the rate of enzyme activity increased gradually. Okay? Yeah. Now, there is also another key important question on when to use initially and when not to use it. We only use the word initially if we are dealing with the concentrations or we are dealing with rates. Now, in that case, if you're dealing with concentrations or rates, there you should start from initially. And one thing to note is initially is a point, not a range. Meaning, you will say that initially the rate of breakdown of glucose is high. But you can't say that initially the rate of breakdown of glucose increases rapidly. No, that is wrong. Initially is a point, not a range. Meaning you can either say that initially the rate of breakdown of glucose is low. Okay? Or initially the rate of breakdown of starch is high. It is a point, not a range. So you have to just say that. And only use initially if you are dealing with concentrations and rates. All questions that go or align with that. Most of the ones which are involving a decrease or an increase, but in terms of breakdown. So it was important for us to note that. So I know we have taken this important. Maybe I think we shall briefly also go through the most common approaches. Of course, we have the most common things being compare. For compare, you must give similarities and differences. Okay? If they ask you to compare, you should give similarities and differences. Now, for similarities, they're always just free marks. I always tell people, I call them BPA. Okay? Always, we should note the peak. The peak has 3 marks, whether in similarities or in differences. That's why in this question is of compare, you should put as many answers as possible. So, usually when you're giving similarities, now, okay, before I even continue, compare. Okay, I have someone from Bukedi College here. Maybe I'll let them talk first before I can proceed. Yes, you can unmute. Bukedi College, yes. I can't hear you.
Good evening, sir.
Good evening to you.
I was asking that if they tell you to write differences, is it okay to just draw a table?
Okay. Let me answer that. I think I will answer that when we reach a table, when we reach the difference part. Let me start with the similarities, because we are coming to it, okay? Yeah. So for similarities, we always start with both or in both. And always for is, first put that thing at the start. Maybe say in both, then you just bullet coming down. Or you can write in all on all statements, okay? So you will say that start, and there the key word is in both or both. Well, that one is not a marking point, but if you don't put it, you don't score. Okay? It's not a marking point, but if you don't put it, you don't score. So both and in both is very important there. So for example, here I put the areas of observation when you're dealing with graphs having such things. The first one is peak. A peak has three marks. There is the peak. I think I gave the difference between a peak and a maximum. So if it is a maximum, we said for a maximum, it increases, then it stays constant up. For a peak, it increases, then comes down or decreases. So you should observe the peak or the maximum. Then how have they reached the peak? E.g., both increase to reach a peak. Okay? So how have they reached the peak is very important. Then what happens after the peak? E.g., both decrease after a peak. Okay? So usually that thing has 3 marks. One, if it is a peak, not before the peak, meaning do they both increase rapidly towards the peak? Do they both increase gradually to attain a peak? Observe that before attaining a peak, there is a marking point there that you can get. Then observe the peaks. How is the peak? Are they both at the same level? So that you said they are both, maybe they both attain higher peaks. Or if they are not, then that one shall be a difference. And then you check the time after the peak. Are they both increasing gradually after the peak? Or are they both are they both decreasing gradually after the peak? Or are they both decreasing rapidly after the peak? So our peak there has how many marks? 3. That you can simply get without over reasoning. Before the peak, during the peak, after the peak. We usually use the word BPA anytime. Okay? Then the second one is point of intersection on a graph. Here you quote the figures on x-axis and the unit where both are equal. For example, don't simply say that, for example, let's say we're using the other graph. You say both respiration rate is equal to, okay, like they both have the concentration rate being equal, maybe. That one doesn't work like that. But rather, you'll say that they both, maybe say they both, let's say they both, have the equal concentration at 1 minute. Or they both have a same concentration at 1 minute. Or they both have a concentration of 19 point something at 1 minute. But the key important thing there is you must note the figure on the x-axis. And then, so here you start with the statement, then the figure is quoted later, just like I said, okay? The x-axis figure is quoted later. Don't say that at 3 minutes, they have equal concentration, you know. Rather say that, now there you see that the word both doesn't work, okay? But you can still figure it in any way. I know you can still trigger in, meaning you can't start with it, but rather you can figure it in. For example, you can say that in both, they have the same concentration at the at the 10th minute, for example. And then another thing is for trends, stroke or patterns, which are similar or range needed. Okay. Here you start with the statement and end with the range. For example, I say that they both increase gradually from 10 to 13 minutes. That's what we are meaning. Okay. Where the range is the same. Like both of them are increasing. Here we use the example of any other observation is according to you is a similarity. E.g., we can check UNEB 2015. In both, the rate of glucose uptake did not reach maximum. Actually, there is, before I answer Morlem's question is, let me first finish this. For example, when you witness 2015, I know most people are always hurry to put it attains a maximum. More so, like I said earlier, I said that when it increases, then levels off completely. We said it has attained the maximum. But when we check the 2015, if someone has a question bank there, that year it didn't reach a maximum because they drew a maximum up. And when you, in the graphs, none of them reached that maximum. So there, could you have said that they both attain a maximum? There you were very wrong, because none of them attained the maximum they had drawn. Okay, so meaning, much as I'm saying, you should also be observant for such graphs. Always read the graph and internalize it well. Okay. Now I can answer their question. You can raise up the hand so that I can easily spot you. Raise up the hand. Okay, you can unmute.
Okay, sir. The question is, like when you're stating for similarities or differences, are you supposed to use also the interval for the x-axis? Like assuming you're saying in both from 1 to 3 days, maybe the rate of respiration was high or what, like that.
Okay, I just mentioned this here on from trends, patterns which are similar, range needed. Okay. Then I say that in this case, it is true you can state it, but end with the range. Don't start with it. Okay. For example, you say that in both, the rate of breakdown of glucose increases rapidly from from 2 to 3 minutes. So you can start with the statement in both, then you end with the range. Okay, as a similarity. Yeah. There is Kamonkoli College here. Okay, I saw there is, okay. Before I go to Isingiro, let me start with Kamonkoli College. Kamonkoli College, you can unmute. Yes.
Excuse me, sir.
Yes, please.
What if you have values on the horizontal axis? Hello?
I can hear you. Continue.
What if the yes, like on the horizontal axis, they have not given you values, but they have given you like time. How do you describe that trend?
Okay. Actually, that is very important. That's very important, actually. We are going to talk about it when we reach such trends, eh?
Okay.
All right.
It's okay, sir.
Okay, let me answer that before. Now, there are times, for example, a single I'm going to answer, don't lower down the hand. There are graphs like 2016 where there were no values on the x-axis. Okay? And usually that one, like for example, I know we always teach using the common trends of x-axis having figures. Usually a student who reaches there and sees the x-axis not having figures, obviously there you freeze. But this is how we handle such graphs. If it is time, okay? If it is time, of course, the x-axis can have time, for example. It can have concentrations. Sometimes it can have, for example, pollution ecology, where we use down the stream or distance from disposure of, from the time they dispose of the sewage up to up to going downstream. I'm going to handle them. I think let me start from concentration. If it is a concentration on the x-axis, then you describe in terms of low, moderate, and high concentration. For example, you say that at low concentrations, the rate of breakdown of starch increases rapidly or increases gradually. Okay. At moderate concentration, the rate of starch increases rapidly. At very high, at high concentration, the rate of breakdown of starch may be increases gradually like that. Okay. If it is time, now if it is time, that's when you bring in earlier and later. Sometimes if it is an experiment, you can say at the start of the experiment, in the middle of the experiment, or at the end of the experiment, or towards the end of the experiment. If it is the distance downstream, then you can relate it with the distance from the point of discharge. Meaning you say that at the point of discharge, the BOD is high. Okay? Then increases, then decreases gradually downstream. And the good thing with such graphs usually is they often ask you to give relationships. Sometimes they don't simply ask you to describe. They ask you to give relationships, which are a bit general. So that someone will say that at the point of discharge, the BOD is very high. But moving downstream, the BOD decreases gradually. And then moving further downstream, the BOD decreases like maybe very gradually, like that. Okay. So here the whole thing is being creative. For example, the one of 2016 had also speed. It had was it speed of water or speed of wind? Yeah, but always we should be creative by introducing in the words of maybe low speed and high speed, something of that kind. But the good thing is for such questions, they ask you to describe relationships, which you can give generally. Okay, I will answer Isingiro. Isingiro, you can unmute. Isingiro Secondary School.
Thank you, sir.
Yes, please. Yes.
Now, on how to describe the peaks, I saw you are just describing the increase and the decrease. But if our graph reaches the peak, then decreases, then again increases, do you describe again the increase, or you just describe the decrease only?
I will show you some of the examples. I will share some of those examples. Sorry about that. It was just a small network issue. Isingiro High, they were telling me about the description of the peaks. So I hope we've talked about that. I'm going to talk about those graphs when we increase, we attain a peak, it decreases, then it gets another peak or even a maximum. For example, the immunity graphs, or even we have also other graphs that show such trends. So now someone says, does this first one become a peak? And does the second one also become a peak? As long as you see a graph increase, gets to a higher point, then decreases, that's a peak. Okay. And then should it increase and then it gets another peak, that's also another peak. I told you, if I told it increased, got up, then decreased. However, we shall take this one as a lower peak and then the other one as a higher peak. Maybe. I see Chitenga. Okay, let me start with Butogota. Unmute, please.
Yeah, thank you, sir. For me, I would like to know, when are we supposed to use the word between when we are describing?
Yes. Chitenga. Yes,
Thank
please.
you, sir.
Yes,
Thank you, sir.
please.
I wanted to know, when are we supposed to use the word slightly when describing a graph?
Oh. Okay, sometimes some people use that word slightly increases, but slightly is the same as gradual. That's why I said we simply just use that GRC for simplicity. Some people use it slowly, but the best is let's stick to the GRC. I think that one is even simpler. Sometimes it's very easy to do a correct thing than explaining why you did it wrong, okay? Let's just use gradual, rapid, constant. Next is Kisoko. Please, after saying you should do lower down the hand so that you can let other people also talk. Which school is this, Kisoko? Kisoko? Unmute? Kisoko? Okay. Buked? Buked?
Thank you, sir.
Yes.
Good evening.
Good evening to you.
My question is on comparison.
Mm.
And I'll take you back slightly to similarities. If
Yes.
I'm giving the similarities, and
Mm.
I find out that my two graphs are increasing, both of them, but the other one is rapid, then the other one is gradual, and I'm giving the similarity. Should I talk about the rapid one and the gradual, or I just say they both increase?
They both increase. I wish you can give that as a difference. If
Assuming
one
I'm
is
giving the
increasing
similarities,
gradually, then the other one is increasing rapidly. State that as a difference, not a similarity. Mm. Okay, Kisoko? 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 Okay, let me get Shine here, and then I'll proceed. Kisoko, are you talking?
Yeah, we are talking, sir.
Yes. Okay. Shine? Shine? Unmute. Yes.
There are some graphs, sir. When they give you, they have a sharp decrease or a sharp increase. Now, how am I supposed to describe such graphs? Because there are some which have smooth peaks, then there are those ones which have sharp peaks. Am I allowed to use words like sudden, decrease, or some words like abrupt decrease, or they are not allowed?
Abrupt decrease.
Yes.
Yeah, there are those graphs, for example, the graphs of, yeah, such graphs can be found there. Yeah. There also even does some graphs which are increasing and decreasing rapidly. For example, the blood pressure graphs, okay? But usually, let's take a peak
Yes.
as a peak, okay? Let's take a peak as a peak. Because usually for such graphs,
Okay.
for example, the one you're talking, which is having sharp peaks, then decreasing.
Yes.
This is an example of predator. The experiment is going like for years. But now, just because of the scaling, for example, they have combined like 10 years on the scale 1 centimeter is representing like 10 years. Sometimes it is obvious to get such a sharp thing. Why? Because this is a big gap. But let's take a peak as a peak. As long as something increases, then decreases, just mention it is a peak. The word abrupt,
Okay, 13.
exponential, we shouldn't be going so much into them, okay? The only thing is that there are times when both graphs are increasing. For example, like one graph has increased rapidly, maybe for the first 1 hour, then it is still rapid, but the change is small. Then for rather, you'll just get a difference and say that maybe at first it was very rapid, then there towards where it has shown a small change, then just that there it is rapid. Okay, but give that difference. Okay, yeah.
Okay, sir.
But for simplicity, let's remain on our words GRC: gradual, rapid, constant. Other than investing a lot of energy in this. Okay, yeah. Shine.
A question.
Okay, I think I see people are very many here. Shine. Okay, Shine is still very far. Maybe let me go to John Paul SS. There is Mubende. Please be brief. I see the people are very many. We might not finish them. Mubende. John Paul SS, you can unmute.
Thanks for the opportunity.
They are not unmuting. Maybe Mubende? Okay.
Thanks
okay.
for the opportunity. So, in your point of the peak reached, where similarities are, in the first point where you have said the peak or maximum, then you have quoted into the brackets. Do not quote figures.
Yes.
Briefly go through it because we don't know whether we do not quote the figures after where the peak is formed, or what are you trying to mean?
Okay, there we are meaning, you said they both attain peaks. As simple as that, eh? Don't say they both attain peaks at 6 months or they both attain peaks at 9 months. No, just simply said they both attain peaks and end there. That's what it meant. There is who else here? Okay, let's give a last chance to Muvende Army. Then we shall, for others, maybe we'll put them in the chat and I'll pick them up towards the end. Yes? Muvende? Yes.
Yes, thank you, sir.
Yes.
My question is that what if we are been given a graph and it fluctuates? Therefore, how will you explain it? Will you rapidly, continuously say rapidly increase, or how can you best describe that graph?
Fluctuating how? Okay, there is this graph. I don't know if you're meaning this one. There are these graphs of blood pressure where
That
like
one.
it is increasing a bit because of the pulse rate, right? I don't know if you have ever seen such a graph.
Yes, sir.
Pulse rate. Now, in that case, you get the mean. Okay? You describe using the mean, like in the middle of it, so that you just give a general instead of giving a fluctuating one. You get me well? Like you'll simply draw a line in between those fluctuations, and you describe in terms of the mean.
Sir,
Yes,
can
please.
you have an example?
I don't know if I can get such a graph here. Maybe I will show you one. Okay, I think let's proceed and we go to the differences. I know really people's hands are up, meaning they have a lot of issues to ask, but you'll have to type some. I will go through towards the end in the chat to answer those questions. Just type them in the chat. So let's go to the differences. Now for differences, we use the words while, stroke, whereas when answering. Where range is required, write the statement first. Then the range areas of observation is recorded as differences. So we always have to use that word while. Now that one I come to a question of someone who asked that, sir, should I use a table? Now using a table is fine. Using a table is very fine. But usually some people misuse the table. How? For example, they can put a difference this side which doesn't coincide with the other side. For example, someone puts that there is a rapid increase. Maybe let's say he decide rapid increase. Like the other side puts something contradicting. Yet when you're stating those differences, they must align. Even just that's why sometimes don't advise students to mostly use tables unless they have been explained too well, like we are going to do today. So if you're using a table, it is fine, but unfortunately, there are some things which want to go which will not fit in the table well. So for now, for these graphs, I would advise you to use the statements. Okay, use the statement form instead of tables for graphs specifically. We shall talk about when to use the tables also, maybe. So for areas to note, we note the peak, stroke maximum reached, usually 3 or more answers needed. And remember I said for the peak or maximum, we have our 3, remember I agreed that we have our 3 answers there, or 3 points. BPA, that's the one thing you should always remember. Before the peak, during the peak, after the peak. I don't know if someone can help me mention for me those ones, always, for any graph which we have. So in this case, we have to note if it is maybe the sugar content graph, meaning the sugar content attains a higher peak, then we use which graph? Let's say, for example, the rate, the respiratory rate attains a higher peak, while the sugar content attains a lower peak. If it is in terms of time, what before the other, then we said maybe the rate of, the respiratory rate attained an earlier peak, and the sugar content attained a later peak. Okay, and then if it is concentration, then say that maybe the starch breakdown attained a peak at a lower concentration, while maybe the other attained the peak at a later concentration. So those are the differences we can give in line with that. And then when were the peaks reached, that one is also important. Here you quote the figure of the x-axis and unit, starting with the statement, then the figure last. How do we state this? For example, you say, Now in here you can use between, it is okay, but much as we should stress on using from. I usually like from because when you become uniform, you don't have to mix up the things. But when you mix up the things, that's when you get the between, you put it where it is not needed. But if you use a general word, it's better. So for example here, you can say maybe the rate of the respiratory rate attained, the respiratory rate has a higher peak, while the maybe the, I think let's pick a graph here, then we describe it. Let's pick a graph here. Yeah, we can describe using these ones. Let's assume that's our graph. Let's start with the similarities. Let's compare. I'm starting with St. Joseph. Yes. St. Joseph. Oh. Teachers. Teachers unmute. When I mention, I mean you unmute, eh? Because your hands are up. Okay, St. Joseph's Hill.
Yes.
Oh, and you?
Yes, good evening, sir. My
Good evening to you.
My question is about the other type of graphs, especially in behavior, where you find like the curve is having zigzag kind of forms. How do I describe such graphs? And also when I'm describing and the question is asked that, okay, like there is no question asking for description, but I'm asked to explain. Do I need to first explain and describe, or I describe as I explain the reasons for the increase or a decrease in any scenario? Thank you.
Okay. Now, if they ask for explaining without them asking you to describe, you describe and then you explain. There you earn the marks. Okay? You describe, then you explain. Meaning there are marks on description before you explain. At times
Okay.
when they ask you to first describe, they can ask you to first describe, for example. Okay? And then when you've described in part 1, then in part 2 they ask you to explain. Then there is no need of describing. But remember, you'll have to describe because you must explain the trend. There is no way you'll jump on an explanation without understanding what you're explaining. So even if they have not asked for the description of the trend, first describe the trend, then you explain. For example, in such a graph, here they first ask you to give a relationship. Okay, you mentioned we gave the relationship, and then in part B they asked us to account for the relationship. Now here you'll first give the relationship, then you account for it. When you finish the accounting for the first one, then you go to the second one. So there is no way you'll explain without understanding the trend. So you have to first state the trend, but then you explain. St. Joseph, St. something. Maybe you can unmute. Unmute.
Thank you so much, sir, for the opportunity.
Yeah.
My question is, how do you answer graphs with homeostasis, especially about temperature regulation, heat loss, and heat gain? Remember, we have the positive sides and the negative sides. So how do you also use the rapidly increasing and the gradual increase, or you just answer normally. I don't know.
Oh, okay. Now, like a decrease is a decrease, and an increase is an increase. Okay, I know even just your conscience can tell you that, like, when something is decreasing, it is decreasing. The only thing is it shall be decreasing in the negative, because you know that when you, as you're moving from zero going to the negative side, still it is a decrease. Okay, so a decrease is a decrease. So you'll be describing it generally. Okay, you don't have to say that again in the negative. It does this, no? Describe it generally. Kabale. Okay, I see many hands up. I know we shall not exhaust all of them if we go through that. Maybe I wanted us to just get an overview of the description of these graphs, because there are some things you can't simply go without. Okay, so let's I think let's briefly talk still about the handling those graphs briefly. Then we can come back to the questions. We continue with them. So we were here on the differences. I hope we were noting some things. Remember, I said for the peak, you have marks on before the peak. For example, you can say that the sugar, the respiratory rate increases gradually, while the sugar content increases gradually from this to this. Remember, I said the range always comes last, the statement comes first. And then we said you can also describe the nature of the peak, which we talked about earlier. For example, one can be a higher peak, the other one can be a lower peak. And then what happens after the peak? For example, one can be decreasing gradually, the other can be decreasing rapidly. Okay? After the peak. I put here a note, earlier and later are only used where x-axis has time. Then lower and higher are used when x-axis has variables other than time, e.g. photosynthesis, okay? There we use lower and higher, but if it has time, use earlier and later. Now, I don't know, I see many hands here, and it's a bit not right to continue without answering this, Okay, St. Bridget, do you have a question? If you have, unmute. Yes? Yes? St. Bridget? Okay. Joel? Unmute. Okay, hope all is well. See many hands up here, but let's proceed maybe. I see there are many hands here, real many. Mugongo, SS Chengera. Yes, you can unmute. Okay, let me come to Kavale, Sanje.
We were asking that when given relationships here, now we having two graphs. Should we start it guys together? For instance, it's a x-axis has time, but there are two graphs. I say from 1 minute to 4 minutes, this graph A did this, as the other graph B did that. That's the question.
Yeah, I think I talked about that at the start. I say that you say from like for example, from 1 minute to 2 minutes, as the respiratory rate increases rapidly, the sugar content maybe increases gradually. Yeah, it was fine. We were supposed to say it like that, for example. Okay, let's proceed. I know we shall be getting a bit more as we go on. Trends and patterns. when asked to compare, write as many points as you can, because those marks can be adjusted. So we said there you have to write many points. Okay, you have to write many points. And then, of course, you always hinted on the statements coming first, then the ranges coming later. Any other differences, e.g. levels within a certain range, starting point? For example, initially, at our initial point, we can say maybe maybe the rate, let's say the amount of glucose maybe was higher than the amount of maybe like something of that kind. So that initial point is important. Then also the way they end. For example, you can say the rate of substrate was very low at the end, while the rate of this was very high at the end. Okay, so there are also some free marks to be earned from there. And then describing trends and changes, I think we talked about that already. Relationships we did. And then rate, concentration, and levels. This one said we start from the initial point. And then range, units first, followed by statement. So we said x-axis first, then followed by the y-axis. Here we say that levels you can use slightly. Which example can we quickly use? Which levels can we easily pick? But if it is rate and concentration, is that you can use gradual, rapid. But for levels, we can use slightly. But still, we can use gradual and rapid, okay, as our points. Then I ended by when there are no figures. Someone asked this, of course I answered it. When there are no figures on the x-axis, what is to describe? I will zoom this so that we can all note very well. When there are no figures on the x-axis, use the words to describe, refer to the factors to the factor on x-axis, e.g. at low temperature, at low turbidity, at slow speed of water, at low dilution, near sewage outfall, longer distance down river, like that. Like you should bring in that creativity. And then before maybe I proceed to anything, we have finished describing a relationship. We said when describing a relationship, you use as x-axis increase, as this factor increases, the other decreases. Okay, but for effect is a bit different. For effect, we quote the x-axis because you are describing in relationship with the x-axis. So we often quote the x-axis, and we have to include the word. We include the effect. That's when we bring in the word results, leads to, or causes. For example, in the case of the other graph we had of respiratory rate and sugar content, then we shall quote it that maybe as the independent, the one they have asked for example, what is the effect of respiratory rate on sugar content? Then we shall say that as the respiratory rate increases, it shall cause an increase in sugar content. So we have here an example. But one thing to note here is here we quote the x-axis, e.g. as temperature increases up to optimum, it leads to or causes or results into an increase in rate of enzyme reaction. Or as temperature increases beyond the optimum, it causes decrease in rate of enzyme reaction. Or sometimes you can start increasing the temperature from maybe 0 degrees Celsius to 50 degrees Celsius increases the rate of enzyme activity or causes an increase in the rate of enzyme activity. So the things we are introducing in during effect are lead, causes, or results in two. But here we should note that we should quote the x-axis because there are those graphs which have more than three things put in one. For example, our graph there, we had the time, we had respiratory rate, we had sugar content. In such a scenario, you should say that increasing the respiratory rate maybe from 0 days to 3 days, it causes an increase in the sugar content. So that's how we state effects. And the following must not be used when describing graphical data. I think this is also very important. There are also people who like using the words like steady, linear, accelerating, generally, uniformly. All those words are very important. Don't use them. It is even worse for people who are doing chemistry, who are doing physics. They are the ones who are so much into using those words, steady, linear, accelerating, uniformly. Please don't use them. Then less more, these are comparative words and should not be used when describing trends. For example, someone can say from 0 to 3 minutes, there is less inquiries. Don't do that. Or there is more inquiries. Don't do that. Okay? Simply put, there is a rapid increase, or there is a gradual increase, or the rate of breakdown is almost constant. If the graph is not drawn to scale, it has just been drawn on a plain paper. But if it has been drawn on the graph and you see the constants, then that the rate is constant. Okay, so this was just an overview of some of the graphs. For example, scenario of 2016. This one gives us the clear picture of people who say that if the x-axis is not labeled. So if the x-axis is not labeled, that's what we do. I've shown you how we could handle it. For example, if they ask you that from figure 1, describe the levels of destruction of the weed by each of the organisms under different conditions of water. In figure 1 of fungus, we could say level of destruction slightly decreases. Okay. Here they use the word slightly, but remember I've said that for us we use gradual. Okay. So here you could say level of destruction gradually increases with increase in temperature. Then level of destruction slightly or gradually decreases with increase in turbidity. Then the level of destruction decreases. Now here they use drops, but that's not right. We are supposed to say decreases gradually with the increase in speed of water. Don't use the word drop or slightly. Okay. I see many hands up. I'll just bring. And then answering that question of negatives. Someone asked the question of negatives. Figure 1 shows the growth of single plant leaf with its import and export of sucrose and phosphorus during period of 40 days. So this one has a positive and a negative. How do we answer such graphs? That's the way we do it. We say that you just keep the trend uniform. Okay? You just keep the trend uniform. If it is a decrease, it is a decrease. If it is an increase, it is an increase. Maybe at this juncture, first let some people speak here. I'll start with the teachers. And you try to be brief. Teachers, unmute. If you're using your Zoom written on teachers. Okay, I think these ones are still a bit far. Oh, and you?
A question?
Yes,
No,
please.
like when they have given you like those graphs of pressure in blood pressure,
Yeah.
and you're supposed to see differences, but the graphs they are like very close to each other, like about fluctuating. Even yeah.
So I'm
Even
saying
like
there
the
is a
graph of
graph on
molting,
growth, molting, eh? Actually, I had prepared
yes.
some question on molting.
Yes. And
Okay, maybe I'll go through them. Should we meet it? Kabale, please be brief like them. Kabale,
My question
Kabale
is,
Sanje Secondary School.
sir, my first question is, in case I'm given a, then in x-axis, time is indicated with the interval of 0, 2, 4, 6, like that, yeah? And time, there are no units given to me, either seconds or hours, as in such. How do I describe that graph? And the second question is, in some growth curves I've ever seen, what this part is used. What
Which one?
SPURT, SPURT.
Yeah.
What is its meaning and how can I use it when describing a graph?
Okay. Okay. Now, usually the graphs must have units. But if they don't have units, then use it the way it is. But usually you have to observe smartly that at least there are always units there because they are the ones which guide you. Otherwise, there won't be any way you can use it. For things which don't have units, they often use parts per million. They often use things like arbitrary units. In any way, if they have given arbitrary units, also use arbitrary units. But use any units which have been given there. But if they have not been given, then also use it just the way it was. Now, usually different topics have their different words. And it is very important because those ones are the ones which guide you on how to attempt. For example, the words like SPURT, overhaul, we have words like SPURT, overhaul. Then we have words like, we have this common word which is used. I forget, it just ran out of my mind. But for each topic, it has its own keywords. So it is important to use it the way it is. So usually SPURT can mean maybe overhaul simply means the cells are rapidly increasing in number. Okay. Sometimes the words like haphazardly are often used. But what I'm trying to mean is each topic might be having its own keywords. So you should use them accordingly. Though the word SPURT, if you're using it to describe, still graphs treat them generally because that is simply part of analysis of data. So bringing in words according to the topic can only work when you're explaining. Otherwise, don't just use a lot of English words. I'll go to Nasasra Amos. Please unmute very fast. Nasasra? Okay, Nakanyonyi girls. Nakanyonyi girls.
Okay.
Yes.
Sir, good evening.
Good evening to you.
So my question is, when you have a graph, and both sides they have values, and that graph consists two graphs inside in it. Okay. Yet like the first one is coming from down, and then the second one from up of the other side. How do you describe the relationship?
Come again. One graph is coming from down. Okay. Now, when you're describing relationships, there are those parts which can a bit confuse. Okay. For example, one might be reaching the peak, but the other one is still continuing, right? To increase, for example. I don't know if you're meaning that.
No.
Mm.
Like, I have a graph, like
Yes.
one plot, but that plot has two graphs. The other one is coming from this side, and then the other one is coming from this side. Okay,
Like,
other one from left, another one from the right.
right.
How do they
Yes.
Yes.
Oh,
how
you're
do they-
meaning, I don't know. Which example can we use? Are you meaning like you have like you have different units on the left and different units on the right?
Yes.
For example, you can use the case of respiration, I mean transpiration rate, and maybe speed of wind. Okay, so that you have speed of wind on the right, then transpiration rate on the left. Maybe down you have time. Did you mean that?
Yes.
And then they're asking you to give
Relationship. Or even
relationship. But like they are not meeting. They are not meeting in any way. Like the other one is far this side and one is far
And
this side.
there is also a point of intersection where they meet.
Uh-huh. Then that one means there is a relationship. Okay? That one means there is a relationship. Because as long as they are crossing, it means that this one has crossed this side and this one has crossed the other side. So meaning within the experiment, there are times when they are both there. Okay? So you should do, meaning there is a relationship. I think the only thing I was thinking was maybe you have this graph. Let's say this graph. Let's take an example of this. And then you have, for example, you want to give a relationship between, let's say, leaf area with the, let's say, phosphorus, okay? And then you say that from 10 maybe to 30, as the leaf area increases. Now here this one is not general for phosphorus. So that means that here you not give a general one, because you can see that as the leaf area increases from 10 to 30, the phosphorus maybe uptake increases rapidly, then it decreases. That one won't be a uniform trend. Okay? But rather now, if it is a case like this, then you'll have to end here, meaning you don't have to reach 30. So you'll have to say that from 10 to 20, as the leaf area increases rapidly, the phosphorus uptake increases gradually. Okay? Nakanyonya, I don't know if I've answered your question. I see you're not comfortable.
Okay, you've answered our question. Thank you.
All right. Next one is, please, when answered, you lower down the hand for is LJHS.
Sir, if
Yes.
they give us like the bar graph, how do we account for it?
Yes, please.
Sir.
Yes.
If they provide us with a bar graph, how do we account? A bar graph, how do we account for it?
Yeah, actually, there was like last year in paper 3. Sometimes people don't understand when to plot a bar graph and when to plot a line graph. I'll give you a scenario paper 3 last year. Now, that one, it calls for a bit of, that's why it's important to attend like such sessions. Why?
Yes.
We only plot a bar graph if we have the our x variables being qualitative. For example, you've been given, you're carrying out different experiments in different test tubes, test tube A, test tube B, test tube C, up to maybe E. And then you put different cylinders with different solutions. And then you're going to measure the final length of the cylinders. Okay? So after you measuring the final lengths, then you're going to they are going to ask you to represent the data on a suitable, maybe use a suitable method to present the data. Now, there is no way you can, they only have the test tubes. You have only the test tube names from A, B, C to E. So meaning on your x-axis, you're going to only put the different solutions, which are, sometimes they can be different solutions. They have been named 0 molar, 1 molar, maybe 5 molar, like that. Those ones are also still qualitative. Or you've used test tubes. That one is also still qualitative. Qualitative is something which maybe you could have assigned a figure, but they are not uniform. They are not continuous. So in that case, you have to draw bar graphs. So you'll have to just put, for example, test tube A, test tube B, test tube C. Some of them have negatives. For example, if you are using the one of, let's say, movement of water, the one of cylinders. So in that case, you'll have to put to note the x-axis and y-axis. I can show you an example of a graph here. An example is there of a graph. Here they gave you an ecologist collected sun leaves and shade leaves from beech trees and determined the mean mass of each photosynthetic pigment in both types of leaf. The results are shown in the table below. Photosynthetic pigment, chlorophyll A, chlorophyll B, then carotenoids, and then the mean mass of each pigment per meter squared of leaf area. In this case, you see that the sun leaves, they were given figures, shade leaves were given figures. These are continuous, meaning you can determine a scale for them. But chlorophyll A, chlorophyll B, these ones are qualitative. They are not continuous. So here you should just simply put them the way they are, and the other side plot a suitable graph to represent the data in the table. And you see the kind of graph here. That's the way we're supposed to represent it. The same could happen for last year's UNEB, paper 3. You're also supposed to present your graph like that. Sometimes it can have negatives. But as long as you see your x-axis having its figures being qualitative, for example, you have been carrying out experiments in different test tubes, or you're using moles, then strictly just put them like that, make them qualitative. Okay, there is Butogota. You're very many, about 7. I think let's proceed and we do some questions because remember this session is going up to only 6. Yes? Yes, please.
Yeah. What I wanted to ask, I wanted to know, like, today I've been faced with a challenge. I was provided a graph and it was showing the relative humidity when there was sunshine, and it was sloping
Togota, your
downwards.
network is not fine.
I put the original curve.
Yes.
I'm saying that.
Yes.
I was told to draw a sketch of that graph, and I put the original curve. And I also indicate a new curve which shows relative humidity during a cold or a windy day. I don't know if you have
Okay,
got
now
it.
in that case, you drew that graph, right? And then ask you to what? To show to also plot a graph on a windy day. And what? What was the other factor?
The first graph I was given, it was showing during when there is sunshine.
Then now they introducing which factors?
And the second graph, they wanted me to draw that. They said I draw that one when it was during a windy day, when there was no sunshine.
Low sunshine and a windy day. Not so?
Yes. Yeah.
Now, low sunshine means the temperatures are low. So the rate of transpiration is also low. But because of the presence of speedy wind often blows away the moisture surrounding the stomata. Okay? Therefore, increasing the rate of transpiration. Meaning, if there is transpiration taking place, so maybe the only difference is it would be a bit downer than the one which I plotted on a very sunny day. If it was a very sunny day, there they simply introducing other factors of transpiration.
Okay, thank you.
All right. Okay, I think you let me go to the other question as I began with, such that at least we do something, okay? I know I've talked about so much of number one. Let's do some part B. I mean, it's paper 2. See, Kabale and Sanje. Okay. Let me get St. John's Liantonde. St. John's Liantonde, you can unmute. St. John's Liantonde. Okay, he's off. I don't know who has not muted. Okay, so you'll permit me go to so let's account for a relationship in A. Where I said you see the chlorophyll is decreasing. There are some people who must mute here. It is these people. Oh, Butogota. Butogota, mute. Good. Okay, so let's do some relationship. Let's explain the relationship. Why was the chlorophyll decreasing and why were the carotenes increasing? Now, we know that chlorophyll is important in photosynthesis, while carotenes are also photosynthetic pigments, but they're not important in photosynthesis. So, the chlorophyll was decreasing. Why? Because it was being broken down by some enzymes and then leading to the formation of carotenes. So carotenes, the chlorophyll was decreasing. Why? Because the photosynthetic rate was supposed to decrease and then encourage the more formation of carotenes. Carotenes are colored. And remember, this is a fruit which is ripening. Therefore, we need more carotenes to act as bright colors to attract the dispersal agents. That's why we had carotenes increase. Why? Because carotenes are colored, and they are going to play a role in attracting dispersal agents. That's why the chlorophyll was being broken down by enzymes. Okay, so that's why the reason that's the reason as to why carotenoids were increasing, to add the color to the fruit to attract dispersal agents. Have we noted that? Carotenes are colored to attract dispersal agents to enable the dispersal of seed from one area to another. That's why it was colored. And then explain the relationship between the content of chlorophyll and, here we have the two graphs actually. Oh, sorry. In B we are describing the A, I mean the B, figure B, figure 1B. So you see that the respiratory rate here, remember respiratory rate is taking place. Why? In B. Because remember, here we are having the conversion of other carbohydrates to sugars, which sugars must be sweet. So at first, the respiratory rate increases rapidly. Why? Because there is a lot of energy needed for the ripening of the fruit. In the way that we need energy to form more carotene to help the plant, to help the fruit ripen. That's why the respiratory rate must increase. But as the fruit is developing carotene, there is also conversion to sugars. Why must we have sugars? As the fruit is ripening, sugars are going to help in the attraction of the dispersal agents to help in the dispersal of the fruit. That's why their content must increase. So the respiratory rate is increasing. Why? To create more energy for the ripening of the fruit. But also the sugar content increases because sugar contents are going to attract dispersal agents. So that's the way we could explain it for B. Then here they put B twice. Explain the relationship between the content of chlorophyll and the carotenes. Now, chlorophyll is broken down as the fruit is ripening, and the breakdown is done by enzymes. Okay, because of increased respiration. You know that when the respiratory rate increases, often here it shall overcome the photosynthesis. Here the carotenes, we say they increase in concentration. Why? Because carotenes are colored, and the essence is to attract pollinators. To attract dispersal agents to disperse the fruit to new areas for colonization. And then what is the ecological significance of each of the changes depicted on the figures? Carotene increase, we say that it is to enable dispersal of seeds to colonize new areas, and the ecological significance is prevents competition. And then sugar content, the increase in sugar content also attracts dispersal agents, therefore enabling the dispersal of fruits and seeds to new areas, therefore reducing the rate of competition for resources. Respiratory rate increases rapidly to provide energy required for the process of ripening of the fruit, therefore enabling ripening that shall attract that shall attract dispersal agents to disperse the seeds or the fruits. And then there is another question here on outline the major other changes which occur in a fruit. Other changes which occur are there is formation of volatile organic compounds like esters that bring up good aromas. There are about a number of processes that take place. Maybe you can just take them from here for now. So our processes are here for D. There is breakdown of cell wall, and that one means that you're going to break down the pectin. Pectin is the one which is responsible for making the cell wall thick. That's why you see that fruits like mangoes, when they are not ripe, they are very hard, but when they ripen, they become so smooth because the cell walls are broken down. Then there is also increased synthesis in volatile compounds like esters. I think I've already talked about that. They are responsible for the good aroma and flavors in the fruits. There is also sugar accumulation because of breakdown of starch to sugars, and that one is also to attract the dispersal agents. And then increased breakdown of organic acids. Like usually there are those acids which make the fruit very bitter, like in mangoes. It is broken down to to sugars to make the fruit become more attractive. Okay, as you're copying, maybe I'll take some questions. I'll take some questions. Okay, it all starts from here. It starts from there. St. Denis, Sebugwao.
Yes. Sir?
Yes.
My question is about the carotene. You said the carotenes are formed while the chlorophyll is broken down by the enzymes. Is it that when the chlorophyll is broken down, is converted to carotenes, or it is just broken down and like that, then the formation of carotene is some other physiologies?
Now, chlorophyll, we have chlorophyll A, chlorophyll B, and carotenes, okay? We have xanthophylls, okay? But in this case, carotenes are just the colored ones. They are not being formed from chlorophyll, okay? They are forming on their own. Like we have clearly put it here. Chlorophyll content of the leaf reduces with the carotene content increasing. They are independent of the other, totally independent. Okay, more hands up. Okay, St. Denis, you can now lower down the hand. St. James here. St. James. St. James, they are not on. Wide. Unmute.
Good evening, sir.
Good evening to you.
May I have a question like, what if they give you a graph and they tell you to comment on it? For example, 2022, paper 1. Yeah, about the comment.
That graph was about what?
It's about
2022.
It's comment on the effects of nervous control on the secretion of gastric juice.
Comment on the effects of nervous control on the secretion of gastric juice.
Yeah.
So meaning the graphs were having that?
Yeah, it's like figure 4 shows the control of gastric juice secretion in a mammalian stomach with increasing time after ingestion of food. Study the figure and answer the questions that follow. On the x-axis, there is meal taken and also time in hours. Then on the y-axis, there is gastric juice secretion. Then they tell
I
us,
get that graph. But now in that case,
yeah,
it seems when they say comment, to me there is something you're going to analyze on the graph and then you relate with the content. Okay? Meaning there were two things. There was nervous and maybe chemical, right?
there is hormonal.
That's chemical. Okay? Meaning you're going to check what's the effect on chemical. What's the effect? Is it high? Higher than the nervous?
Nervous is high.
So those are the differences you're going to state. Why is for nervous high than the one for hormonal? Because you know, nervous is always the first, not so. Because of the nervous, that's when you get the hormonal. So that one simply need you to make that analysis. Check how is nervous? Yes. Yes, please.
It means like differences. Comment.
No, you first identify that difference in the graph. Okay?
Yeah.
After identifying that difference, now that's when you will explain the difference.
Okay.
You can mute, and then we go to A and U.
My question is about the chlorophyll being broken down.
Yes.
I thought it is the one that manufactures the starch in the fruit. How come that it is being broken down? How can it be broken down?
Okay. Now remember this is a fruit. It is nearing senescence. Okay. At this rate, we only have growth inhibitors circulating in a plant. We have ethylene and abscisic acid that are responsible for aging. So that's why because of those circulations of those hormones, that's why you'll see that everything is coming to an end. The plant's photosynthetic rate is going to decrease. Why? Because it is coming to an end. But remember here we are considering a fruit. This fruit has a high concentration of aging hormones. We are not having any growth promoters. We don't have any gibberellins. We don't have any cytokinins. We don't have any auxins. Here we only have abscisic acid and ethylene, which are responsible for senescence, meaning this particular plant or this particular part of the plant is nearing its end. So there is no need for more chlorophyll to make more starch. Rather, the need is now to have carotenes and have those hormones convert the starch to the sugar, which is more sweet and attractive to dispersal agents. That's why the chlorophyll decreases. Okay, its concentration decreases. Why? Such that it enables carotenes to make the fruit look colorful to attract pollinators. And all this is coming because of the hormones, the coordination. Because right now this particular fruit is growing old. There is no need of it making more starch, but rather the starch is enough. Therefore, it should be converted to sucrose or fructose, which is more sweeter to attract dispersal agents. That's why there is no much need for the chlorophyll at that age or at that particular time. Next one is Kabale. We are summing up, We are summing up.
Excuse me, sir.
Yes, please.
Previously, you talked about drawing a bar graph. Now
Yes.
I would like to know how to describe it, describe that bar graph.
Oh, describing a bar graph. I only describing a bar graph. Of course, that one is a bit general, because a bar graph is often just something like grouped. Okay, so it is you should just do a comparative study with another group. For example, you're going to compare the percentage increase in length or the percentage change in length in test tube A with test tube B. But it is a bit impossible to describe a bar graph because these are bars, and bars mean this is grouped data. I mean, like let's say they have put maybe number of people of group A, of blood group A, blood group B, and blood group O in, let's say, Kampala. So you have a plotting for that. Then you have another group, blood group A, blood group B, blood group O of Mbarara. Then you have another group, blood group A, blood group B, blood group O of Kabale. So that one makes it like you can't describe the way we describe it for line graphs. It is a bit impossible. But only you can describe in groups. There is Kasao. Yes.
Yes, excuse me, sir.
Yes, please.
I'm inquiring, Master, when we are writing a bio essay, can we use those columns when we are stating
which columns?
The columns, what they call the marking points?
Oh, marking points.
Yeah.
Yeah, actually, I hope we can find up sometime and then we go through the whole of that. One time we did it. Actually, it is already on YouTube on Holistic Learning Platform. Yes. If you can find time, maybe you can follow it up. Otherwise, if you find up some more time, we shall go through how to answer paper 2 and how to break up those points. We mentioned a number of things like making a content map, forming a rubric, the number of things you must follow. But in biology, of course, keep noting that it is only key points. Always minimize on a lot of English you're using and stick to the key points for a particular biological topic. Those key points are very important. There are times like when some people say high concentrations, low concentrations, maybe when they're describing graphs. Well, there are times when we must not use that. We must say increased concentrations, decreased concentrations. Maybe I know the time wasn't enough and it was more of interactive, so I have not touched a number of things, but we shall keep interacting in the WhatsApp group and many more. I also have left the contacts there. You can call it just in case of anything, but also these lessons are on Holistic E-Learning Platform on YouTube. You can simply type in Holistic E-Learning Platform and you access them.
Yes. Lastly, we have graphs like those ones of molting, which increases, increases and then remains constant, then increases. Should I go on explaining each, or maybe describing each phase, or I can describe at once?
Now there you have to be a bit, okay, I don't know one, but you can be, if the decrease is within a very narrow range which you can't determine on the x-axis, then you can go general. But if it can be determined on the x-axis, you go specific depending on the trend. Yes. For example, I said like the one of blood pressure. There you can get the mean and you describe, because there they are fluctuating at a rapid rate. So yes. There you can get a range in between. Then you describe in terms of the mean. So for example, say the mean blood pressure from maybe 0 to 5 seconds is rapid. Okay, like that. But if the range is really not so big, then use the trends and the range.
Yes.
Napaka CDSS. Napak CDSS.
Ask. Good evening, sir.
Good evening to you.
Okay, I wanted to inquire, how can you answer the questions like whereby when you are given 2 graphs and one factor is varied, then how can you identify that one factor is the one which is acting as a limiting factor? For example, this one's of photosynthesis and its factors. How can you identify that it is either carbon dioxide or sunlight which is acting as a limiting factor?
Okay. Now, a limiting factor is that factor which is occurring in less amounts. Let's say we have optimum light intensity, we have optimum carbon dioxide concentration, we have optimum
chlorophyll, but just maybe one factor now is the one which is less. That one shall become the limiting factor. Okay? For example, that factor which is decreased, or the one which is below the required, is the limiting factor there. S-nut, S-nut, S-nut unmute. Okay, S-nut must be very far. We go to Togota, Trinit.
Yeah, thank you, sir. What I wanted to know is all about carotines, accessory pigments, and what I say, marking guides. When they are writing their S's in paper 2, they use semicolons. Am I allowed also to use semicolons like when I'm writing my S? Thank you.
Oh, okay. Those semicolons mean marking points, okay? Those semicolons mean marking points. And that's why I say that the key points are very important. Also, if you think those are the key points, then you can set them like that. Because in biology, it is key points that help you score. So if you're also sure that that is the key point, then you put it with a semicolon. But always think about minimizing on a lot of English use. Stick to the key biological point terms used. Okay? For example, here instead of saying spreading of seeds, rather use dispersal of seeds. Okay? That one shall be important for you. So, please, those semicolons mean marking points. They are not just put there. They mean marking points. If you can also state them like that, well. But for you, if the points are different, then each point starts on its own line. Description is, please, I always like putting each description on its own line for simplicity of marking. X-axis, Y-axis, X-axis, Y-axis, like that. Morlem Gauss. Morlem Gauss.
Yes.
Yes.
Yeah, thank you, sir, for your contribution. Sir, I wanted you to help us know how to describe like this graph on the population growth. That one which was brought in 2009, number 45. It is extremely hard for us to describe it.
I don't know what's hard with it.
It's like it's having three different graphs. There are three and they're circular. They're cyclic. You cannot understand it very well.
I don't. Okay, can you read the beginning?
It's saying
that
that
introductory statement.
It's like show the three figure 6 shows three population growth curve pattern A, B, and C that occur naturally, and so the thing is cyclic from A to B to C, and others are increasing rapidly. Then it will again decrease. They are having like three. Yeah, they're having different what the graph says.
And unfortunately, I don't have a question bank nearby here. How cyclic? How cyclic? How?
It's moving like wave, like waves. Like wave.
Like what? A wave.
Yes. Up and down.
Okay, increasing up, coming down rapidly.
Yes.
Yeah.
Oh. And have I asked you to describe it?
Yeah. That describe and suggest regions for the observed pattern of
each graph or each curve. Okay, in that case, that's what we're talking about. If the time is really on the x-axis, if the scale is fitting, then describe them the way they are. For example, have those graphs of predator-prey relationship, where the description might seem the same. Okay, they are fluctuating from, let's say, from 1 year to 10 years. Then we could bring in the word fluctuating. For example, said from we said from maybe 5 to 10 years, there is a fluctuating increase in the number of prey. But if I've not just got that curve very well, but if the time was really enough on the x-axis, then we could describe it part by part, just like I said in the start. St. Denis, Sebugwao, I really see people are very many here, 10 plus. I don't know. I look for those who have not asked before. DOS A level. Benison. Okay, I think let's mute all. Okay, I've unmuted all of us. I know the disorder is going to be there, but you can unmute and you talk.
Sir, for me,
Yes,
what
please.
I wanted to know is about if you see the enable of last year.
Yes, please.
In paper 3, there was a graph.
Okay.
Yes.
Okay.
And that graph required us, it was not having whenever it was a reduced graph. So when you could measure it, you could find when it could not reach 1 centimeter, like those 5 small boxes. So what I want to know is that did they require us to measure 1 centimeter physically by ourselves, or it was just those 5 small boxes?
Okay. I made a mistake to unmute everyone, but I know we're in the end. So you'll choose to listen by muting. Okay.
Hi.
The graph. Okay. Graphs of UNEB are different from the ones used in your graph papers. So always adjust and use them the way they are. Always stick to the 5 small squares, which are 1 centimeter. In biology, you consider 1 centimeter, not 5 small squares, okay? So always adjust it and it fits you. Okay, next one. Okay, I see we already so much into our time, by 10 minutes. I'll maybe liaise with Mr. Kaziva. If possible, he can schedule for us another one of this kind. And then we discuss more issues. More so concerning
excuse
biology.
me.
Yes, please.
Excuse me, sir.
Yes, please.
I would like to know the effect of light on the synthesis of lipids. How can you explain that one?
On what?
On the
in transpiration. I mean, in the photosynthesis.
In the photosynthesis, the formation of lipids in the presence of light.
In plants. Of course, that one, we know that lipids are going to be formed at the point of acetyl-CoA, where we talk about the fate of the products of of photosynthesis, the acetyl-CoA. And that's the key marking point, because it can go into the respiratory, it can be used in respiration, or it can turn into fatty acids, which are stored as lipids or fats. Okay, at the point of acetyl-CoA. So, and remember,
Good evening,
acetyl-CoA is
sir.
also going to come from photosynthesis. So you must track it from photosynthesis. Formation of acetyl-CoA is either going to form fatty acids, or it is going to be used
We
into
don't talk about graphs of reproduction.
respiration.
Reproduction.
Yes, please.
You haven't talked about graphs of reproduction.
Which ones?
Reproduction.
I didn't get you well.
You've not talked about graphs of reproduction.
Oh, the hormones and others.
Yes, those ones.
You know, today as meeting we a bit did a lot of things more so concerning graphing. All these questions are part here. All of them are here, but of course we couldn't exhaust all of them. Like you see, have all graphs here that we're going to handle. All these ones. And this is a graph
Are you going to
talking
be there
about.
on Rambogo Seminar?
Okay?
Are you going to be
But
there on Rambogo Seminar?
hopefully next
Excuse
time,
me.
we are going to schedule another one and then we can handle it.
Soft
Definitely.
Excuse me, sir.
The last question, sir.
Yes. Scrolling.
The last question, sir.
Yes.
Sir, I would
Okay, there
like to
is
know
this.
how phytochromes control flowering in tobacco.
Now the most active form is PFR, phytochrome far right. That simulates
Sir, can you share the graphs
flowering.
in soft copy?
Okay, I know we can handle all this.
Yeah, in soft copy.
Now, I know our time is already used up. Maybe, just like I said, we can get all this information. Yes, please. Yes, please.
I wanted to know I may get this information on this laptop.
Yes.
I wanted to know how I can get this information on this laptop.
Wanted to know how?
How I can get this information on this laptop because I don't have enough time.
Okay, you can get this from YouTube, holistic learning platform. Help. You can put it in YouTube. Also, my contacts are here. You can meet me on email. The email is here, and then contact is here.
Excuse me.
Yes.
Can I use words like gradual, rapid, or like slowly when I'm giving effects?
We say that you use gradual, rapid, or constant.
When
Effect, we say that you quote the x-axis, then you use the word results, causes, or leads to.
Okay, so we don't use the word rapid, gradual.
No.
Okay.
Okay. For more information, that is maybe for more consultation, but all this work is on YouTube. You can simply type in holistic learning platform. Also, you can type in that. For more information, you can search them out. The contacts
Excuse
are
me,
here.
sir, before you go.
Yes, please.
Excuse me, sir, before you go.
Yes.
Excuse me, sir.
Yes.
Excuse me. Sir, I
I
have
can
a
get you.
question.
Yes.
Let me first give you a hint, sir. It's all about osmosis. Let me first give you
Yes.
a hint. What this means about the
About what?
It says annex together behaves in
what?
sucrose concentrate. An investigation
Yes.
was carried out to investigate the behavior of plant tissues.
Plant tissue.
Yes.
In plants.
Your network is not so good, eh?
They gave in a table. Are you hearing? We are in a village. Now the sucrose concentration went on increasing from 0.1 0.3 0.3,
Okay.
0.4,
Now, sorry,
0.5.
but what you're talking, I can't get it well. Like, you can simply you can go to YouTube, you search for holistic learning platform. There are many lessons there that we have conducted there for senior 6. Secondly, also the contacts are here. If you want to check on me personally, my email is here. Contacts are also down here. I know the time wasn't enough. This one is for only 2 hours. Next time we shall organize hopefully another one, and then we'll all be in. Okay. I know we could have wished to continue with this up to very late. It's done limiting. I'll request one person to give us a closing prayer.
Closing prayer, we're here.
Who can give us a closing prayer?
No,
Closing prayer. Closing prayer. Who can close for us? Closing prayer.
Hello?
Yes, sir.
Who can give us a closing
Yes,
prayer?
Starting the closing prayer.
Let us pray.
Yes.
Sir, the closing
Okay,
prayer
I
is here.
Do it.
Let us
Let me first mute all these ones.
Our Father in heaven. Look what me, O God, as my hands I lace you. You, O I turn, since I use wisdom. Humble yourself for your own prayer.
Okay. See you soon.
We are starting the closing prayer. Humble yourself. Look what
Yes.
look what me, O God, as my